With Weaviate's new hot, warm, and cold storage tier release, you might be wondering how you can best manage your resources to balance search speed, accuracy, and costs. We have just released an awesome guide, so let's go through it. Before we start with the decisions, let's quickly review what hot, warm, and cold storage tiers look like. Hot storage holds a vector index in memory, so it's super speedy and primarily driven by our HNSW type vector indexes. It's also always available for users, so it takes the most amount of resources to keep running. Warm storage stores the data on disk, making it slower than hot storage but less expensive. It's driven by the flat index for vector search, object data, and inverted indexes. It's also always available for users, but has significantly less memory usage than hot storage, so it's much cheaper resource-wise. Cold storage is data that has been offloaded to the cloud, meaning its resources are not available for immediate use. So it has the slowest of the three because you have to warm it up to make the data available, but it's also super cheap. There's lots of decisions here to balance performance, cost, and data accessibility. The three main levers are choosing the vector index type, using compression techniques, and managing flexible tenant states. Let's start with the vector index. There are three different types here. If your tenant has more than 100,000 objects, it's recommended to use HNSW or the hot storage type to avoid performance costs. If your tenant is under 100,000 objects and most likely going to stay there, then you can use the flat index or the warm storage type. If you're not sure if your tenant is going to stay under 100,000 objects, then you can use the dynamic index. This means that it will start as a flat index until the number of objects reaches a certain threshold, and then it will move to an HNSW index. What about compression? Weaviate currently offers three compression techniques: product quantization, binary quantization, and scalar quantization. Compression techniques can help lower resource costs and even speed up searches, but it's important to choose the right type and also balance with accuracy considerations. If you have a small collection that uses a flat index, or if you're using the HNSW index and don't have a representative sample of your final dataset, consider using binary quantization. The BQ index is 32 times smaller and much faster than the uncompressed equivalent. If you have specialized needs and a very large dataset, consider product quantization. PQ compression is very configurable, but it requires more expertise to tune well than SQ or BQ. If you don't care so much about tuning parameters or just want somewhere to get started, then scalar quantization is a great choice. Most users with medium to large datasets should consider SQ compression. SQ compressed vectors are 1/4 of the size of uncompressed vectors, and searches with SQ are much faster than searches with uncompressed vectors, while maintaining similar precision and recall. Finally, Weaviate supports three tenant states: active, inactive, and offloaded. If the tenant always needs to be available now, then you're always looking at an active state. If it doesn't need to be available now, but might need to be made available very quickly, then you can set it to inactive, meaning it's locally stored but not available for immediate use. Otherwise, the tenant can be offloaded to cold storage, which means it's not available for use and can take a little bit of time to be brought back to active. It might be a good strategy to deactivate tenants that are not frequently accessed and offload tenants that are rarely accessed. The flexibility here in all the different storage types and resource management helps us support you in building all different kinds of use cases. And we really want to make sure that you're getting the most out of your Weaviate instance. This awesome guide is linked in the description above, and you can always reach out on our community Slack with any questions.